Welcome to Splunk Tech Talks. Our security edition today is focused on shifting left in DevSecOps and detecting malware like cryptojacking that was injected via a supply chain attack early in the software development lifecycle. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customers, and want you to continue in your Splunk journey, and we want to give you innovative and cool new ideas how to maximize value out of Splunk. I am Angelo Brancato, a security specialist at Splunk based out of Munich, Germany, and I'm excited to share with you this session today. We are going to talk about how malware can be injected in a very relevant and current way via a supply chain attack, how we can shift left in the software development lifecycle and detect the indicator of compromise early. We will run through a quick demo depicting the major moving parts, and at the end we will share some additional resources. And if you have any questions, please continue the conversation on the Splunk Tech Talk community at splunk.com/techtalk. So let's say we are a company building apps and we follow DevOps best practices for plan, build, test, release, operate, monitor, and response. And let's also assume that we do that in the cloud, leveraging all benefits that the cloud-native DevOps practice brings to the table, like continuous integration and continuous development, to be agile and first on the market. But typically and unfortunately, IT security is oftentimes an afterthought, meaning the application will be monitored for attacks and indicator of compromise after it is being deployed in operations, when it is exposed to the world. When adversaries find a vulnerability in the running code, they try to exploit it and inject their malicious code to achieve their actions and objectives. And with that, the cat and mouse game begins. If we are able to detect that indicator of compromise in time before they can achieve their goals, we win. Else, if we give the attacker enough time to achieve their goals, they win. But adversaries have a much better foothold and persistence in the victim's environment if they achieve to infiltrate their malicious code into the source code while it is being built. If they achieve that, the malicious code is an integral part of the application, distributed to all customers downstream, and thus much harder to detect at a later stage because, well, there doesn't need to be an intrusion, they are already in. And that's why we in the security industry coined the term of shifting IT security left in the software factory, making IT security practices an integral part of the DevOps process, sticking security right in between dev and ops, so to say, making it DevSecOps. Securing the software factory, respective DevSecOps, can be basically grouped in three categories. Securing the code, for example with static code analysis, securing production, for example with dynamic source code analysis, runtime application protection, vulnerability scanners, security posture management tools, etc., and securing the software factory in its entirety by ingesting logs and metrics from all point solutions and correlating these for security violations and indicator of compromise. Now let's have a closer look on this and how we can get started with shifting left. As we said, we have a multi-cloud environment and we need to monitor multiple public cloud service providers as well as on-premise data sources. And we assume that our organization uses distributed Kubernetes containers and clusters for development, staging, and production. Getting visibility with Splunk is pretty straightforward, as we can ingest data directly from the entities and also get extra context from the security and audit tools that the cloud service provider offer. In this session though, we want to look at real-time metrics and how to use metrics to detect indicator of compromise very early. So let's look at the attack vector in our demo setup. We said that we have smart adversaries that themselves shift left and try to infiltrate their malware at the build stage. For doing so, they use a supply chain attack called dependency confusion, where they exploit the behavior of public source code repositories such as PyPy, NPM, and Ruby gems. The attack in general flows as follows. First, the attackers scan public Git repositories for manifest files that have package names that are used internal only, like in this example that has been published by the researcher Bison, the ones in red. Second, the attacker places packages with the exact same name and a higher version number onto the public repository. Third, when the developer pulls those packages in the build process, the package manager either just gives the public repo a higher priority or gives the package with the higher version number the higher priority. Either way, the attacker has injected the malicious code into the build process and infected the organization. In our example, the malicious code is crypto mining code based on XMRig that is stealing CPU resources and mining Monero coins for the attacker. And we want to use Splunk observability and SOA suite to detect and remediate that, ideally automatically. For the detection, we use the most reliable metric that points to crypto miner, and that is CPU usage. For orchestration and automation, we will craft an exemplary playbook that handles the triage and incident response. If we put that onto a timeline, the cloud environment is monitored by Splunk infrastructure monitoring, collecting real-time metrics, and we have detectors in place that will give us incident notifications whenever these detect abnormal CPU usage. That incident is forwarded to Splunk Phantom, our SOAR solution, where the cryptojacking playbook is triggered. The SOAR playbook will then update the notable event in the theme, Splunk Enterprise Security, and will also trigger remediation steps. So let's jump right into the demo. First thing we do is to browse to splunk.com, navigate to Products, Splunk Infrastructure Monitoring, former SignalFX, and sign up for a 40-day trial. Once we logged on to the SaaS service, we make sure to set up the credentials for our major public cloud providers that we want to monitor. Next, we set up the connection in between Splunk Infrastructure Monitoring and Splunk SOAR. In order to receive incidents from infrastructure monitoring, we enable the Phantom REST API app and copy its URL for incoming messages. Then we go back to infrastructure monitoring, select integrations, and add a webhook where we paste the REST API URL that we just copied. For the webhook header, we need the REST API key. So we go back to Phantom, Administration, User Management, and we select the automation user where we copy the REST API token and paste that into the infrastructure monitoring dialog. Now that the connection is established, we can enable some alert templates. And as we want to be alerted for high CPU usage, we'll select the detector high CPU utilization percentage that will just trigger if an entity exceeds 99.999% CPU usage for more than 10 minutes. As a recipient for the alert, we select the webhook that we just created, which will send the alert right down to our Phantom SOAR. Next, we select the detector CPU utilization percentage greater than historical norm. This one will trigger whenever the CPU utilization for the last 10 minutes is greater than 3 standard deviations from the normal load over the last 24 hours. And we also add Phantom as a recipient. Third one is the detector CPU utilization percentage greater than the normal population, which will trigger if the CPU utilization of the particular entity is above the median of similar entities in the organization. And you already guessed it, Phantom as the alarm recipient. So now we laid the foundation of getting visibility into our multi-cloud DevOps environment with Splunk, and we get real-time metrics from our AWS, Azure, and GCP environments. Right now, everything looks fine, and we don't have major outliers in terms of resource consumption. But this is about to change because I will start a Monero mining process on some of the containers manually to simulate the malicious code infiltration. And sure enough, here is the first infrastructure monitoring alerts that point to that exact container with the detector alert CPU utilization is significantly greater than the normal and increasing. Now let's switch over to the automation layer where we see those alerts coming in. If we select one, we can see that we don't have any related activities because we didn't assign any workflow or playbook yet. But under artifacts, we see all the context information that came via the alert. Now let's create an exemplary SOA playbook for triaging this alert. We go to Playbooks and select Add Playbook. And with that, we get an empty playbook with a start and end point. In between, we can now place whatever should happen automatically, and the most important building block is actions. Actions come with apps and are basically the interface to your IT ecosystem. More than 300 apps come out of the box, and the one that you see here are the ones that I already configured and work in my environment. So we could select the Splunk infrastructure monitoring app and the available actions get presented. We can clear the incident, get further incident details, list other incidents, or run any query we define. And that action result can be forwarded as an input for the next app and the next action. We could choose to use the incident details about the container to request a privileged access token from our key management solution that could be a HashiCorp vault. We could then log in via SSH and execute any CLI command that we may choose. Or we could query the Splunk indexes or update a notable event in enterprise security. So that's the very first step when creating a SOA playbook. Select the app that interfaces with your environment and configure it with your credentials. Now let's look at an exemplary playbook that automatically triages the cryptojacking alert that we got from infrastructure monitoring to give you some inspiration for your environment. And I will not go into full details, but go through the logic and touch briefly on every action and explain what it does. First, we use the SignalFX app to get details about the Kubernetes container. Then we request SSH access credentials from the HashiCorp vault. The next step is the SSH app, which logs on via SSH onto the container and gets the processes that are causing or caused the high CPU load. Next, again via the SSH app, we get the parent processes, the scripts and executables, and the directories where those reside in. With all that context information, the playbook will now execute parallel investigation actions. It will query the SIEM, in this case Splunk Enterprise Security, for any related notable events. It will query the MISP threat intelligence platform for any IOCs related to those files and processes. It will run Yara scans on the containers to not only rely on file hashes, but also to scan for strings, patterns, binary data, and behavior that relates to crypto mining. For example, detecting mining pool protocol strings in executables. It will query the Splunk Cloudsploit index for any misconfiguration of the cloud environment. And it will also post artifacts to VirusTotal as an external scanning engine. All that context will be presented to a security analyst in the Security Operations Center that can then, with a single click or touch on a screen, route the incident to the right individuals via Splunk on call and can also launch another playbook that does the remediation. For example, quarantine the respective entities for forensic analysis and auto-resolve the incident in Splunk infrastructure monitoring. which then will close the loop. We're about ready to wrap up this tech talk, but before we do so, I want to share quick the resources available to you to continue your journey. You will receive these assets also in a follow-up email as well as the recording. Don't forget that we have an incredible community of Splunk users on our community site. You can continue the conversation for this talk within the discussion section called Tech Talks, where you find all additional resources. And finally, there is Splunk Ideas, where you can submit new product enhancements or vote for current ideas from other customers. We really appreciate you taking the time out of your schedule to join us today. Please tune back in for future tech talks. We are excited to share the series with you. Thank you and take care.